You ever stop and think about how you actually communicate with all the technology around you? I mean, every single tap on your phone, every click of your mouse, it all happens across this invisible bridge. It's a connection we use all day, every day. But what is that bridge, really? Let's dive in. So really, how do you do it? How do you tell your car to navigate to a new address? Or tell your computer to open a specific file? You're not speaking its language of ones and zeros, and it's definitely not speaking yours. There's got to be some kind of translator, right? A middleman.
And that's exactly it. It's a bridge that connects what you're thinking and what you want to do to what the machine can actually execute. It's a bridge we cross dozens, maybe even hundreds of times a day, and we don't even think about it. Well, that bridge has a name, and honestly, it's the key to our entire digital world. It's called the Human-Machine Interface, or HMI for short.
The easiest way to think about it is that there are three parts to any interaction. First, you've got the user. That's you, with a goal in mind. Then, you've got the machine, the computer, ready and waiting to do a job. And finally, right in the middle, connecting the two, you have the interface. That's the bridge.
So, an HMI isn't just one single thing. It's this whole collection of hardware, like your keyboard, your screen, your mouse, and software, like all the buttons and menus you see on that screen. All of it works together just so you can tell a machine what to do.
And you've probably heard a bunch of other names for it too. Things like user interface, or UI, or graphical user interface, GUI. They're all different facets of the same really fascinating field that's all about one thing: making it easier for humans and technology to work together.
Okay, but this isn't just some abstract idea for engineers. The way these interfaces are designed has huge real-world implications. We're talking about everything from the code it takes to build them to some pretty serious consequences when they go wrong.
And it's so easy to underestimate the amount of work that goes into building these bridges. For a typical piece of software, the interface alone can be almost half of all the code written. And for web apps, get this, that number can shoot up to a staggering 80%, just for the interface. Which brings us to a really critical point. For you, for me, for anyone using the tech, the interface isn't just part of the product. The interface is the product. Think about it. If the interface is clunky or confusing, who cares how brilliant the technology is behind it? For the user, the product has failed.
And a failure in interface design can be so much worse than just a bad user experience. It can be incredibly costly, and in some really tragic cases, it can even be deadly.
I want you to consider the crash of an Airbus A320 in France back in 1992. It was a terrible tragedy that resulted in 87 deaths. And a major contributing factor was traced right back to the design of the cockpit's interface.
The investigation found that a single control, one knob, was used for two totally different yet absolutely critical functions: the plane's vertical speed and its flight path angle. This created a critical ambiguity for the pilots who were under immense pressure. It was one tiny interface design choice, with the most catastrophic consequences imaginable.
Thankfully, we've learned so much from mistakes like that one. The history of the HMI is really a story of moving away from that kind of confusion and complexity and towards clarity and intuition. So, let's take a quick look at how we got here.
I mean, in the early days, you had to be a total expert just to use a computer, feeding it these complex punch cards or typing in cryptic commands. But then, in 1968, a guy named Douglas Engelbart gave what's now called the mother of all demos and introduced the world to the mouse. And everything changed. By the 80s, we had computers where you could directly manipulate things on a screen. And that progress just kept accelerating, taking us through the first glimpses of augmented reality, all the way to the multi-touch screens that are just second nature for us today.
But this whole evolution wasn't just about getting better and better tech. No, it was driven by a complete revolution in the way we think about design.
See, for decades, the philosophy was machine first. It was all about the tech. The attitude was, here's this powerful machine. You, the user, need to learn how to adapt to it. But then, this huge shift happened towards a user-first approach. The new philosophy was totally radical. The machine has to adapt to the human. The focus wasn't on what the machine was capable of anymore. It was on what the person needed to accomplish.
And the ultimate result of that user-first philosophy is the graphical user interface, the GUI. This is the world we all live in now. Icons, windows, pointers. Instead of memorizing a bunch of commands, we can just point, click, and drag. We weren't being forced to think like a computer anymore. The computer was finally starting to think a little bit more like us.
So, what's the bottom line here? What are the big takeaways? First, the HMI is that absolutely essential bridge between us and our machines. Second, getting that bridge wrong can be incredibly costly and sometimes tragically dangerous. And finally, that whole journey from complex command lines to the intuitive touchscreens in our pockets was powered by one huge idea: putting the human user right at the center of everything.
The evolution of that bridge has literally changed the world. We've gone from physical cards to typed commands, from a mouse to our own fingertips, which leaves us with one last, really fascinating question to chew on. What's the next bridge going to look like?